Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the parallel session of the International Conference on Nuclear Science Technology and Application 2020. We are now in room 9 with the topic of environment science and nuclear for industry. We really appreciate your participation in this conference and hope you will enjoy and stay until the very end of this session. My name is Maksun. I work as a researcher in Division of Radioecology, Center for Technology of Safety and Radiation Metrology, National Nuclear Energy Agency of Indonesia. I will be the moderator for this session. Before we start this session, please allow me to read the guideline for the smooth running of this session. To the operator, please show the guideline. Okay, I think I will not read all of the guideline. Anyway, you can read the guideline in this slide. But you must be attention that the time is very limited. We have to strictly control the time. For invited speaker, you have 25 minutes, including Q&A, and for oral presentation, you have totally 15 minutes. And as you might already know, there will be awarded for 3 best presenter for all rooms and a best observer for each room. Therefore, for all presenter, please kindly do your best in delivering your presentation. And for all observer, kindly be active along the session. Do not hesitate to ask questions. Now, let us proceed to the next agenda, which is a presentation from our invited speaker, Dr. Danat Sengchandar. How are you, Dr. Danat Sengchandar? Hello?
Hello.
I'm sorry if I mistake to pronounce your name.
No, you're correct. Your pronunciation is correct.
Okay, usually it's very difficult for me to pronounce Thailand names. Thank you for your joining in IconStat 2020.
Thank you.
Very glad you have here. Before he starts this presentation, I would like to read his short CV. He graduated in master degree in the field of nuclear engineering, Chulalongkorn University, Bangkok, Thailand. He also graduated in the same field for his PhD. Work experience in Thailand Institute of Nuclear Technology. He started his career as nuclear engineer. In 2017 to 2019, he is a head of nuclear technologies surface for industrial application section. In 2019 to now, he is a head of radiation measurement and assessment section. And he also has expertise, research reactor operation, radiographic testing, digital radiographic testing, column scanning using gamma ray technique, industrial compute tomography, neutron backscattering technique, and also dosimetric calibration. In this time, Dr. Danat Sengchandar will talk about application of neutron backscattering technique in estimation of sludge settled in the tank for 20 minutes. There will be 5 minutes for question and answer. So please raise your hand when you want to ask. I will choose 1 or 2 persons to ask directly. For the person who do not have any chance to ask directly, you can write your question in chat box. Now, let us hear the presentation. Dr. Danat Sengchandar, you can share your screen now. The time is yours, please.
Hello, can you hear my voice? Hello?
Okay.
It's okay, right?
Yes.
Okay. How are you? Okay. Thank you very much for your introduction. And this is my first time of the web presentation. I'm a little bit strange when we have to dealing with the kind of the new normal. And anyway, today I will present you some application in the industry. Since I have been working in this field for a while, maybe about 15 years, and mainly I working with the gamma ray, but recently, about couple years ago, we have studied the neutron backscattering technique. So that is become of the presentation today. Let me introduce a little bit where I'm calling from. This is the outline, and then we will go for the brief principle, and then we go directly to the effect to the neutron backscattering in the principle, and some demonstration cases. There are the three cases that I like to raise because it may give you some idea of your further work. This is a map of our region. I'm in this Thailand here, and this is a Jakarta. It's about 3.5 hours by flight, and I'm calling from the location nearby Bangkok. And this is our offices. We have three campus. Thailand Institute. We have three campus. The one campus is in Bangkok. Another one is the headquarters. Is about 70 kilometers away from Bangkok to this location they call the Nakhon Nayok. And this is the Klong 5, another place that we have the electron beam. So I'm now calling from the headquarters site. In our organization, we have several services and research reactor, mainly for the nuclear and the research and development for agriculture, radiopharmacy, materials, and so on. And also we provided a lot of services. For myself, I'm come from this part, the Nuclear Technology Service Center, in which under our center, we provide some service for element analysis, radiation measurement and assessment section, and also the nuclear technology service for industrial application that I will present today. These are the work we are working on. We have the column scanning, we have the non-destructive testing, we have the radioactive source services in situ, like if they want to refurbish their element or the equipment, we can just like disassemble or assembly it. Also the neutron backscattering and support the ISO 1724 for the non-destructive personnel, and also industrial tomography and tracer. And these are our work now. So as everybody knows that the capability to penetrate of the radiation to the materials are different. And for example, if we talk about the alpha particle, then you can stop it by paper, beta, you can use a thin plastic, gamma ray, you can use the lead or other neutron, you can use a hydrogen-rich material. And with this idea, we can perform some kind of the application by using their characteristic, like for the transmission. This the radiation transmission technology, we dealing with the gamma ray or X-ray, and also the radiation emission, we dealing with the gamma ray, and radiation backscattering, you can dealing with either gamma ray, X-ray, or neutron. And for the principle of transmission, this I think everybody in the radiation field know it very well. So we have a source in one side of the specimen that we want to test, and it will penetrate and attenuate it, and we use the detector or film to get the attenuated radiation remaining, and the remaining radiation intensity will follow by the Beer-Lambert's law by this equation. These are the example of the application of gamma ray. We apply it to the radiography, like the film, for the film radiographic, then we can have some picture. And nowadays the technology has developed a lot, so we can just irradiate and then we get the picture there right now by digital radiography. The next is the column scanning. This one allows us to study the internal structure of the column as well as the operating condition of the column. And it brings a lot of the advantages, this technology, toward the industry. In Thailand, we perform many columns. Let's just say that we inspect the column about 70 columns a year in Thailand. And other application, we can use this application to determine the blockage of the fouling pipe by using the gamma ray. The next technology is the next technique is emission. The emission that you have to put your source, or anyway, in any word, other words, you can have to mix it homogeneously to the medium that you wanna inspect it and let it go by the medium. So what you get is the characteristic of your system. It will reflect the behavior of the system to you. For example, if you want to have the flow measurement, you can use this technique to measure it, or RTD, resident time distribution, leak detection, or heat exchanger leak determination. With this technique, it allows you to online diagnostic. It's similar to when you go to the hospital and doctor inject the little pharmacist into your body to diagnostic your body. And this is the topic that we're gonna emphasize today is the neutron backscattering technique. In this technique, we use the properties of neutron when they collide with the medium, especially when they collide with the hydrogen-rich medium. It will reflect some characteristic of the neutron by slowing down the neutron, and sometimes it leaks out of the place that we want. But finally, there are also some part of the neutron that modulated and backscattered back to the detector. And if you compare this technique when we use the neutron probe nearby the equipment, then the neutron will modulate with the medium and then part of the backscatter. Compared to the air, the neutron may or may not interact with the air. Anyway, it is very few chance to backscatter to the detector. And with this application, we can use it for many ways. In many ways, the probe itself composed of the neutron source, which is the N collector. This is the red one. It is a fast neutron, and the detector is the helium-3, in which it is detected only the slow neutron. This picture shows you the equipment that we are using. So we use the americium beryllium as a neutron source. The intensity is about 800 millicurie, and we use the Ladlum model 16 with this is a remote probe for containing the radio neutron source and the neutron detector. If we look the side view of we look on this side, we can see that one of the side is a neutron and another one is a detector. If we look for the top view, we can see that the neutron source is at the middle of the probe, and the detector is gas field, in which it is along the length of the probe. The way that we perform the testing is we have to move detector, the probe, along the side, and most attach as much as we can to the place that we want to inspect. Then the reflection of the neutron will reflect as the neutron count rate. Then we come and plot it when it passes to the water, in which there are a lot of hydrogen, and compared to the hydrocarbon, and there's less hydrogen compared to the water and the air. So by this pattern, we can categorize what happened, what is inside the tank. And we can use this technique with the horizontal pipe also. The way that we do is we move the probe along the periphery of the pipe to see what happened inside. The first picture, we fill that pipe with the water, 100%. So you can see that this is the plot of the water itself. And if we compare with the half water, 50% water, so you can see that the difference of the plot occur here. You can determine the interface of between water and air. And if we fill the bottom with the sand deposit at the bottom of the pipe, this phenomena, the behavior of the neutron backscatter is a little bit different. So you can categorize that this is the water part in which the neutron cloud is approximately here, and the air or a deposit. And when we combine that, when every sample, that we can get this curve. And the life should much easy if there is nothing interfere, but most of our life also composed of interference. For example, when we use a neutron to measure your system, you have to consider many humidity or the atmospheric at that time. For example, on the rainy day and on the sunny day, so you can have a very different of the background. One thing that occurs, you can see that there is ambient humidity that interfere your probe, and also as well as your body, because 70% of our body is water. Then the neutron come all the side, front and back. So when the neutron come back to your body and then it bounce back as well to the probe, that interfere the measurement. Another is the floor humidity, the water or some that the soil evaporate from the soil could interfere your probe as well. So these factors becomes very significantly to your precision of the measurement. Then how can we deal with this? We have to consider the neutron count as a background at the ambient. This one you have to keep into your consideration. And also at most, you can keep the distance from yourself to the probe. You can still work. There are two purposes of this distancing. Like that we have to keep the radiation safety, and also the reduce of interference to the probe. And next, the measurement of the neutron count at the background every 10 centimeter up to 50 centimeter or more to ensure that this interference will not interfere your probe. And when you use the measurement to the specimen that you are testing, you have to keep all of these parameters and subtract it in the proper way to obtain the true value, to the good value. And next, we have to know how much the penetration ability of the neutron to work into the distance. descend in perpendicular to the probe. With this experiment, we put some layer of the water with this picture show you the testing pipe, which is covered by the insulator. And we use the same type of the insulator, but we fill with the water to see if we move the water, the detectability has changed or not, or how much is effect to our neutron. Then we try many cases. For example, dry pipe, 100% filled with the water pipe, and we stack the moist insulation or some relocation of the moist insulation as well. And we move the probe along the periphery of the pipe, all the sides along all the circle. Then we plot like this. So you can see that if we put the water near to the surface of the probe, then we can obtain very high backscatter. On the other way, if we put it more far, the neutron count is become lower. And from this experiment, we can make some more or less conclusion that if you use the neutron backscattering technique to inspect your specimen, please, can penetrate about 20 centimeters from the cladding inside, and it backscatter. There are many purposes why only 20 centimeters, but one of the most significant that is the self-shielding. If we expect that a long of this are full with the water, then it comes and some of the neutron may not be able to backscatter, passing through the self of the medium to the probe. So that is the reason why we cannot see it more than 20 centimeters. And anyway, because of the neutron behavior is based on the cross-section of the medium, and that becomes like more statistically issue. And the value when we measure the point of that we want to test, then we have to consider the uncertainty of that point. So because at first we make like 3 measurements and make average for 1 point, and then we move next point, 3 measurement and average it and plot. The thing happened to us that was it was not the thing that we expected to see the result. So we have to determine what is the good thing for that measurement. With this equation we developed from some standard deviation and standard to mean deviation ratio of this. We have to make some criteria. For example, if you measure 3 times, then you can have your average measurement. And with this average measurement, you have to see your standard deviation of your data. And with this percentage, so we strict that this must less than 5% in each point of measurement. But actually we prefer 2%, less than 2% of the standard uncertainty that gonna satisfy our measurement. If the measurement is greater than 5%, so you have 2 choices. One is increasing the number of the measurement and just recalculate until the uncertainty is less than 2%, or you cancel all the measurement and restart at that point, new 3 points or 5 times, something like that. But if you get 2% of satisfactory, so it means that your data measured at that point is not so much different. And so the processing of the data, first, when we get some engineering drawing from the client, you have to determine the scanning location. What will you see? What will you want to see? And we have to determine the probe moving step. For example, your tank is about 20 meter height, but you move 1 single centimeter for each step. It's not nonsense for that. and it consumes a whole day for that implementation, which is not worth for us to do. And you have to consider the interference that I talk about, and also the measure the neutron count at the design location. Then calculate the uncertainty and repeat if it is necessary. And in case of the horizontal vessel or pipe, have to convert the data from the periphery movement to the height. In this thing, I will show you the result, but actually it is just like the algebraic mathematics that you can just project from the curve to the height. This is not so difficult. And plot the neutron count versus the elevation. With this demonstration, I will show you some three cases. One is the sludge deposition in the tank, storage tank, and the sand deposition in three-phase separator, humidity or water accumulated in the concrete pillar. This is not a tank, but I think it is very interesting maybe interesting for you as well, but it is very interesting for me when we got the request of this job. So the story I will tell you one by one. First, we talk about the sludge deposition in the storage tank, and the objective is to determine the deposition of sludge level in the storage tank farm, and the use of study to predict the sludge level in the storage tank. The tank is about 20-meter diameter, and we use americium beryllium, neutron probe, neutron source, and helium-free detector. And we were in the petroleum tank farm branch. So this is the tank. The height is about 1600 millimeter, 16 meter. And the measurement elevation for interval is about 5 centimeters. It means that we move the probe 5 centimeters each and scanning from the bottom to the top. So you can see that the tank is sitting on the floor. Then the interference is directly come from the bottom. So this one should be considered. And we just move along the way vertically. But at the first 2 meters, we have to measure four places like this to see the plot. And this is the result of that plot. So you can see that there is the sludge accumulated at the bottom, because one of the side shows that there is some plot like this. And at the top, we can see the interface between the liquid and air level in the tank form. So from the interpretation, we can make a conclusion that interface of the liquid and air is about 12 meters, and sludge accumulated at about 2 meters in approximately. So the next one is the sand deposition in the three phases of separator. This is the horizontal vessel, like you can see this. And the diameter is about 4.5 meters in this diameter. We use the same equipment, and this is working offshore. So they want to see that how height of the sand accumulated at the bottom of the tank. So we select the location of the scanning at each S1 to 5 and S9, 6, 7, 8, 9, and 10 in each location that we interest in, and move the probe from the top along the periphery of this in each location. Each step we move about 10 centimeters or 2.54 degree, but this is more difficult to measure in degree, so we prefer to move in the centimeters per step. And this is the thing that we use a tape, measuring tape here, and just move the probe along this periphery of the tank and make a count. And finally, this is an example of the plot. Then this is the scanning number 10, scanning line number 10. So we have this kind of the plot. We can see the interface between the air and the liquid inside, and this is a deposition. And with this all data, we can make kind of this the picture and tell the plant that you have this phenomena occurring in your vessel. So this is the last example that I'm bringing you. It is the H-beam in which you can see in many structure in the plant, in the refinery plant or other plants. And normally the constructor should cover this H-beam with a concrete perfectly. But one day we got the telephone that they call us. They want to put the fire distinguisher attached to this pillar. But when they drill the hole, then the water come out from that hole. So they don't know what happened actually. They expected that the concrete is not penetrated fully into the H-beam until it occurs some hole inside, and that accumulate the rain water inside that hole. So we make this specimen setup using this H-beam. Then we partition it with the iron plate, metal sheet, and have some filling the water into here.
Sorry,
and make a concrete pipe.
5 minutes more.
Okay, sir. So this is the scanning the equipment that we use. We expected that at the 0 degree and 180 degree, like this side and other side, should have the same plot. And 90 degree and 270 degree should have the same plot as well. But the thing that is not happen. But from this is a dry pillar. We don't fill any water. So we can see the moisture inside the concrete very well. But when we fill the water, it is something like we expected. It's not the same thing that we see. You can see that at 90 degree and 270 degree is not come together. But anyway, we can see the interface of the water phase and the moisture inside the pillar. So we just expected that we curious it's what is happening. So we use the computer tomography and make the computer tomography of this pillar. So you can see that it's not the balance both sides. This side of 200 yet at the 90 degree is not the same of the 270 degree. That becomes of the plot of this, not the same line. So I come to the conclusion that is this neutron backscattering is really powerful one of the radiation technique that we can apply to the industry. And the advantage of this, sometimes you use X-ray, you cannot distinguish the difference of the density between the deposit and the like oil or something like that. It's not it is really very difficult to interpret the result. And this result help the plant to prepare the waste management, especially for the toxic waste. And this is a very powerful, useful for them. Anyway, the radiation of the neutron is very, very concerned issue. So when you work with a neutron, you have to care about it because the weighting factor is about 20 times of the gamma ray. And thanks to our team, this is the person who carry out the work, including me. And so thank you very much for your kind attention. Any question, please?
Okay, thank you very much, Dr. Sain Chanter.
I have to stop, right? Stop the sharing.
Okay, you can stop yours.
Okay, okay, sir. Thank you.
Okay, thank you very much, Dr.
Yeah.
Janet Changchandra for your nice presentation. You have 5 minutes for question and answer. Anyway, as you know, maybe that the sludge from oil or gas usually as a phenol.
Yep.
So that contain radioactive material. So
Pardon?
yes, phenol usually contain radioactive material.
Yes.
So is there the different treatment for non-radioactive sludge?
The treatment of the sludge, actually, I have no idea of that because we just got the request to just scan it and tell them how height of that sludge, and that we don't know how do they treat up of that. Sorry for this.
Okay, you usually only on gas and oil.
Yes.
Okay, and maybe you know that there are many methods to estimate the sludge in to estimate the sludge deposition.
Yes.
And
Yes.
what is the benefit of this method?
Mostly for using the neutron. So you can clearly see this is the sludge and this is the mixed water or oil or hydrocarbon. That is clear. But when we using are we talking about the radiation technique? When we use the gamma ray or something like transmission, uh, the density of the sludge is not much different from the medium like water or oil. So more difficult that you can see the graph, the significance of the difference. In my experience, I don't know if there is other non-nuclear, non-radiation technique to inspect it or not, but I just compare it as my experience. I think it's more clear than using the gamma ray.
Okay, thank you very much. Maybe there is one question from our observer here.
Yes.
To Dr. Sugiarto, please ask directly.
Yes, thank you very much.
Hi, Suki.
Hi, Danas.
Hi.
Thank you very much for joining the conference. Very interesting.
Yeah, thank you.
Yeah, our problem is that how to use the neutron scattering to predict the distribution of the sludge in the tank.
That is really very difficult because as I presented, the range of the neutron can penetrate I think not more than 20 centimeters from the surface. So you can just estimate at the surrounding, the periphery of it, but you cannot tell anyway at the middle of the 20-meter tank. It's not penetrate to that. But you can just estimate the surrounding that if the surrounding is high, so definitely more higher at the middle. But one thing you have to care about because you have to see what is the inlet of the tank. The inlet of the tank will tell you the accumulation of the sludge might probably be there more than other places. Okay.
Well, maybe you know there is maybe some commercial software to predict the distribution of the sludge. Is there commercial software?
I asked the brand how do they inspect their sludge. They said that just use the very long stick.
Stick.
And long stick and just put it there and then just measure. By maybe you can use some kind of weighting rope and then you just put down when then the rope is just like not so tension. That is mean that it becomes to the sludge on the sludge. Other technology I don't know actually. Mostly they use this expectation to prepare the logistic of the waste, right?
Right.
Yeah. Mostly of the how to say that they overestimate the size, the volume of that waste. So the plant want to reduce this cost. I think when you tell them, you have to have some how to say that margin value to them, that this is not exact, but a little bit exceed the value that you expect. For example, you say that 10 tons, it's 10 tons, maybe 20 tons, 12 tons, something like that.
No, please, yeah.
Yeah.
Have you experience with the using of thermograph? Thermograph.
Thermograph.
Thermo.
No, I have not experience of that.
Oh, okay. So it is not help our our measurement. Yes, actually, the new neutron dextrine is the best.
Yes.
For
Yes.
Measurement of sludge in the tank.
Yes.
So thank you very much.
Thank you very much.
Yeah.
Nice to see you all.
Thank you very much for Dr. Janet Sengchanter and Dr. Sugiarto for your nice discussion. But anyway, that the time is limited. So again, thank you very much to Dr. Sengchanter for the wonderful discussion and remarkable presentation.
Thank you very much for your promotion.
So please wait here.
Okay.
Here we would like to give a certificate as a small appreciation.
Okay.